Hi, alright, so we're going to do the coffee can demonstration for Chapter 7 on plate tectonics. If you already watched the video on Chapter 7, you heard me say that there was going to be a coffee can demonstration to illustrate what a hypothesis is versus a theory. You might find that strange, but this is actually a pretty effective demonstration. So just at first, I just want to talk about the difference between some of these terms. So a hypothesis is simply a guess at the outcome of an experiment. Okay, so it's short-lived. You know, you could either find evidence to show that the hypothesis is true, or you can show that the hypothesis is false and you would reject it. A theory, and you notice in Chapter 7 that plate tectonics right now is simply a theory. It's a long-standing hypothesis that has yet to be proven false. So all a theory is, it's not a law. A law would be something like, when I apply a force to something that has mass, that object is going to accelerate. Now that's a law. That is going to happen no matter what. But a theory is simply something that hasn't yet been proven false. It is the prevailing theory that right now plate tectonics describes the motion of the oceanic and continental plates on Earth. All right. Okay, so here's how we're going to do this demonstration. It's going to actually require you to do some things. So I'm going to mention to you right now off the bat that at the end of this, if you can come up with a hypothesis as to how this center coffee can works, and you let me know about it, I will give you some bonus points on exam 2, just like I had a bonus for exam 1. So here's what the first thing I want you to do. I'm going to show you some of these coffee cans. Maybe you can notice some differences right off the bat. But what I want you to do is, I'm just going to leave these coffee cans like this, okay? And I want you to pause the video. And I just want you to write down some facts and observations. So these are just things that you notice about the coffee cans that are just absolutely true. And I'll tell you some after you're done hitting pause and writing some things down. So go ahead and hit pause now. Okay, here are some things that are true about these coffee cans that maybe you couldn't observe from just looking at the picture of this video. Alright, these are made out of aluminum. Alright, if you know anything about old metal style coffee cans, is that they're made out of aluminum. So all three of these are aluminum. They're metal. Each has a plastic lid that's blue. Okay, this one does not have any plastic labeling around the circumference or the outside of the cylinder. This one does have a plastic outer covering. This isn't paint, this is a plastic outer covering. And then this one also has a plastic outer covering, but it's slightly different than the middle one. One huge difference that you probably wrote down was that 2 out of the 3 cans were smaller in size to the center one. Okay? What I'll do is I'll show you the inside of the smaller cans. And by the way, this isn't supposed to be a magic trick, although it kind of seems like it's setting up to be that way. Here's the inside of that coffee can. Pretty nasty, but it's the inside of it. Now here's the thing with the big can. Just like the plate tectonic theory, we can't go into the asthenosphere and take measurements and figure out if plate tectonics is actually a law. Is it actually happening? So I'm not going to show you the contents of the middle coffee can. All I'm going to tell you about it is that it's battery operated. Alright, it's a battery operated coffee can. Okay. Alright, so now we're going to do a few experiments with the coffee cans. First thing I'm going to do is I'm going to place 2 of the smaller cans apart, so you should be able to see that pretty good in the video. And then what I'll be doing is I'm going to be placing the coffee can down on its side, allowing it to roll this way or roll this way. Alright? Now, depending on what I do to these cans, it may affect the outcome of the roll. We're not sure. So here's what I'm going to do. I'm going to put both cans like this. Alright? I'm going to take this middle can and put it down, and then I'm going to let it go. And that's how each experiment is going to work. So here we go. Alright, it doesn't seem like that did anything. Having both cans in this specific orientation. Alright, so let's try something. What I'm going to do is I'm going to flip this can upside down so the plastic lid is in contact with the table. And I'm going to take the can I'm going to put it here, and I'm going to let it go just like I did before. Oop, I got it away, so let's do that again. Here we go. I'm going to let it go. It seems to be rolling in that direction. Alright, so there's one thing in any scientific experiment that's important, and that's repeatability. So let's just make sure we can do that again. Okay, let's see if it rolls in the same direction. Okay, it seemed to work just fine. Alright, so maybe you have an idea about what's going on. I'm not sure, so let's try something else. Let's flip it this way. Let's try it again. See if it does anything. Alright, it didn't do anything. Now let's flip the, we'll call it the polarity. We'll make this one be plastic down, and this one be metal down on the table, and then we'll do our, oop, now it went towards that one. Let's see if it's repeatable again. Okay, it seems to be, maybe attracted over to that one. Alright, let's try something. Let's try 2 plastic down. Let's see what happens. Okay, nothing there. We already tried 2 metal down. Alright, let's go back to that first case. So the first case was we had this one plastic down, I believe. Alright, so let's try it now. Now, remember what we said about repeatability. Things need to be repeatable. So we should be saying this, the same thing happening over and over again if our hypothesis is going to be proven to be true. Alright, so we have metal down, plastic here, and let's see which way it goes. Last time, I'll remind you, it went over to that one. You can rewind the video and see. So let's see what happens. Oop. Now it went over to that one. Alright? So here's what I want you to do. I want you to come up with a hypothesis about what you think is going on with this middle can to make it move the way it did. And I'll say one last thing. There's one more idea that you have to think about when you're doing any experiment in any science. It's called Occam's razor. Occam's razor says that the simplest explanation for a given observation, the simplest explanation tends to be the true observation or the true hypothesis. So, keep that in mind. Try to figure out what's going on with this can. If you can figure it out, and you email it to me, I will give you bonus points on exam 2. Otherwise, at a later date, towards the end of the you have to have this in by exam 2. After exam 2, I'll put a video and I'll show you what's going on with our battery-operated coffee can. See you later.